This lesson you will learn about trigonometry. The objective is to use the sine, cosine, and tangent ratios to determine side lengths and angle measurements in right triangles. And that's really all that trigonometry is. The tri in trigonometry refers to triangle. Metry is measure, so it's the measurements in a triangle. The side measurements and the angle measurements are what you calculate in trigonometry. In this lesson in particular, we're only going to be concerned with right triangles and the measurements in a right triangle. So our first statement says that similar right triangles have equivalent ratios or fractions for their corresponding sides that are called trigonometric ratios. Trigonometric. Trigonometric ratios. So in this particular triangle, we have angle A, and the side opposite angle A is a little letter A. And then we have angle B, and the side opposite B is a little b. And then we have angle C, which is the right angle in this triangle, and the side opposite it is the hypotenuse of the triangle, little c. So those are the letters we're going to use to reference the angles and the sides of this triangle. So if you look at the ratios below, you have the sine of A, which is abbreviated SIN, sine of angle A, is the length opposite the A, angle A, which is lowercase a, divided by the length of the hypotenuse, which is C. So it's just a ratio, it's just a fraction. It's the length of A and the length of C. The cosine of A, cosine is abbreviated COS, cosine of A, and it's just a ratio, a fraction of two sides of this triangle. And it's going to be the side that is adjacent to angle A. The side that's adjacent to angle A is side B. It's beside it. It's not the it's the leg that's beside angle A that's not the hypotenuse. Okay? So the length of leg adjacent to A is B, and then the length of the hypotenuse is C. So your ratio for cosine of A is going to be B over C. And then finally you have tangent. So the tangent of angle A is going to be the length of the leg opposite angle A, which is lowercase a, over the length of the leg adjacent to it, which is the lowercase b. So tangent of angle A is going to be the fraction or ratio A over B. So let's look at something to help you remember this. SOHCAHTOA. SOHCAHTOA is an acronym, which is something that helps you to remember the order of the sides that go with each of these ratios. So the SOH part, that represents sine. Sine of A is opposite over hypotenuse. So you have the S, the O, and the H form the SOH for SOHCAHTOA. The CAH part of this acronym stands for cosine. Cosine of angle A is equal to adjacent over hypotenuse. So the C, the A, and the H are the CAH of SOHCAHTOA. And then finally, you have the tangent is the TOA part, and tangent is opposite over adjacent. And that's the T, the O, and the A part of SOHCAHTOA. So that acronym will help you remember the correct order for the sides to get the right ratios for each of those. The next definition is for an inverse trig function. If you know the sine, cosine, or tangent ratio for an angle, in other words, you know what the side measurements are, but you don't know what the angle measurement is, and you want to know the angle measurement, you can use an inverse. You can use an inverse trig function to find the measure of the angle. So that is the only time you will ever use inverse sine, which it looks like sine raised to the -1, but that's called inverse sine. There's also an inverse cosine, and there's also an inverse tangent. And you can see these on your calculator, but the only time you will use inverse sine, inverse cosine, or inverse tangent is when you want to know the measure of an angle. So just keep that in mind when we're working the problems. The last thing on your notes is to use an inverse. You're going to use an inverse when you know two sides of a right triangle and you want to know the measure of one of the acute angles. That's the only time you're going to use an inverse function. The other thing that's not on your notes that we need to cover, and we will cover these in your problems in your assignment, but I want you to have it on your notes, the formulas for this. There are reciprocal trig functions, so we need to write these down. The reciprocal trig functions just means that the reciprocal of sine is going to be cosecant. The reciprocal of cosine is secant. And then the reciprocal of tangent is cotangent. Once again, we will use these in your assignment, but just to have these in your notes so you can reference it. You can abbreviate cosecant, CSC. So if I want the cosecant of angle A, that's going to be the reciprocal. So you're going to take your sine function, which is normally opposite over hypotenuse, and flip it. So it's going to be hypotenuse over opposite. Okay, which in the triangle above, the first triangle we were referencing, that's going to be C over A. For secant, the abbreviation is SEC, secant of A. This is the reciprocal function for cosine. Cosine is normally adjacent over hypotenuse. So that means that secant is going to be the reciprocal of that. So it's going to be hypotenuse over adjacent. And in our triangle at the top of the page, that's going to be C over B. And finally, cotangent is the reciprocal function for tangent. Abbreviate that one, COT, cotangent of A. Normally tangent is opposite over adjacent, so the reciprocal of that will flip it and have adjacent over opposite, which in the triangle at the top of the page is going to be B over A. This will all make a lot more sense once you actually start applying these to some problems. So let's go look at the problems on the right side of the page. In problem 1, we're going to use trigonometric ratios to find the sine, cosine, and tangent ratios for angle P. So the first thing you should do is mark angle P so that you can know which one's sides are opposite and adjacent to it. So the sine of angle P, sine is opposite over hypotenuse, and the opposite side, opposite angle P, is 15, and the hypotenuse, which is always the side opposite the right angle, is 17. So that's all you need to write for the sine ratio for angle P. The sine of angle P is 15 over 17. It's a ratio of the opposite over the hypotenuse from the perspective of angle P. Look at cosine of angle P. Cosine is adjacent over hypotenuse. So from the perspective of angle P, the adjacent leg is 8 and the hypotenuse is still 17. So it is 8 over 17. For the tangent ratio, tangent of angle P, tangent is opposite over adjacent. So from the perspective of angle P, the opposite side is 15 and the adjacent side is 8. So that is the tangent ratio for angle P. And that's all that you need to write for those. You don't even have to plug anything into your calculator. You don't touch your sine, cosine, or tangent buttons on your calculator to find those ratios. You're just writing the fractions. In problem 2, we're applying trig ratios. It says a cliff forms an angle of 84 degrees with a lake. If you stand on the edge of the cliff and drop a rock at a height 48 feet above the water, how far from the cliff will the rock strike the water and round to the nearest whole foot? You need to draw a picture of this for this to make this make sense. So we have a cliff coming out over the water. So here's the water. And you're dropping this rock. So it's forming a right angle with the water. And you're 48 feet above the water when you drop it. And it says it's making an 84-degree angle. The cliff forms an 84-degree angle with the lake. So this angle over here is 84 degrees. And you want to know how far from the cliff will the rock strike the water. So you want to know this other side of the right triangle. How far away from the cliff is it? So we have an angle, and from the perspective of this angle, 84 degrees, we know the side that's opposite it, and we want to know the side that is adjacent to it, which trig ratio has to do with opposite and adjacent. That's tangent. So let's set that up. Tangent of 84 degrees, the tangent of that angle, is equal to opposite over adjacent. Opposite that angle is 48. Adjacent to that angle is the side we want to know, the x. So you're going to have to solve for x. And to do this, it's helpful to use a property of proportions that we had. If we make this into a proportion on the left side and make it into a fraction so that we have a proportion, if you remember the property of proportion we used, where we could switch the means, but we could also switch the extremes. So if you switch the extremes on this problem, then you'll have it set up like you need it to be to solve it. So if I switch this, it's going to be x is equal to 48 over tangent of 84. So all I did was switch the extremes in this proportion, and it solved for x. So if you put that into your calculator, you're going to get 5.045, which is approximately 5 feet. to the nearest whole foot. Problem 3, you got to find the measure of an acute angle right triangle using an inverse trig function. So here it wants to know what is the measure of angle T to the nearest degree. So you look from the perspective of angle T. I know the opposite side is 7, and I know the hypotenuse of this triangle, the side that's opposite the right angle, is 13. So I have opposite and I know hypotenuse. So that means the trig function you need to use to do this is sine, because sine is opposite over hypotenuse. So the sine of angle T is equal to opposite over hypotenuse, which is 7 over 13. So in order to find the measure of angle T, let's swap these and use an inverse function. So we're going to use the inverse sine of 7 over 13 is going to equal the measure of angle T. If you put that into your calculator, the inverse sine of 7 over 13 is going to be 32.579, which is approximately equal to 33 degrees. In part B, looking again from the perspective of angle T, I know the side that's adjacent to T is 8, and the hypotenuse is 10, the side that's opposite the right angle. So adjacent over hypotenuse, which trig function is that? That's cosine. So cosine of angle T is equal to adjacent over hypotenuse, which is 8 over 10. So if I take the inverse cosine of 8 over 10, that's going to give me the measure of angle T. So put that in your calculator, you will get 36.8699, which is approximately equal to 37 degrees for the measure of angle T.